All right, good morning, everybody. This is going to be our first formal lesson with the new unit, Pythagorean Theorem and Irrational Numbers. I know a lot of you have already had a chance to work on this focus area, but it's actually also a unit, okay? Pythagorean Theorem and Irrational Numbers. Now, for this one, the work I'm going to be assigning is going to be a little bit different, okay? So I am going to be asking y'all to actually copy these notes in your notebook as you're going through the videos, okay? It's going to be very important that you pause the video if something's not making sense and definitely post it on the YouTube link or send me a message or something. You can't just sit back and say, oh, I'll be fine, okay? So to go ahead and get started, we're going to introduce some notation. And these words, Pythagorean Theorem and irrational numbers, they'll come up eventually, okay? We need to introduce some notation, some new symbols, and some of you have already seen this symbol right here, okay? We call that the root symbol, okay? So whenever you see that, you're going to think, oh, it's the root. But it's going to be like, you can take different types of roots, right? You can take a square root, a cube root, a fourth root. So we're going to go into that in a bit, okay? And the opposite or the inverse of a root symbol is going to be the power, right? When you raise something to a power, something like squared, okay? So these are opposites of each other. Just letting you know. Okay? So first, let's look at squared numbers. As I said, you should be writing this down in your notebook, okay? You can pause it if you want. So squared numbers. Squared numbers are numbers that are multiplied by themselves, okay? So the number 1 is a squared number because 1 times 1 is 1. The next squared number is 4 because 2 times 2 is 4. These are also called perfect squared numbers, okay? What are other perfect squared numbers? 9, because 3 times 3 is 9. What's 4 times 4? 16, right? 25, 36, right? 5 times 5, 6 times 6. And just follow the pattern, okay? 49, 64, 81, 100. I'm going to keep going because you need to be able to identify perfect squares. That's 12 squared. 13 times 13 is 169. 196. 225 is 15 times 15. Actually, I don't know. 17 times 17. I'll stop there. But, as I said, if you see one of these numbers and it has to do with square roots or whatever, or powers, just know that these are all perfect squares. 1, 4, 9, 16, 25, 36, 49. And that's because 1 times 1, 2 times 2 is equal to these numbers, okay? While we're here, let's go ahead and think of perfect cubes, okay? Similar reasoning, a perfect cube is a number that when you multiply it by itself 3 times, it equals that number. So for example, 1 is a perfect cube because 1 times 1 times 1 is 1. Oh God, what did I just write 2? 2 times 2 times 2 is what? 8. 8 is a perfect cube. What's 3 times 3 times 3? 27. Notice how they're getting a little bit bigger a lot faster, right? 4 times 4 times 4? 64. 5 times 5 times 5. 125. 6 times 6 times 6. I think it's 198. 36 times 6. 30 times 6 is 180. 180 plus 36. Oh, wait, that's 216. 7 times 7 times 7. Well, 7 times 7 is 49. And I know that 50 times 7 is 350, so I just remove 1 7, so that's 343. And you can keep going. I'm not going to go after 8. Those are two. Actually, 8 is pretty doable. That would just be 2 to the 6th. But it's important that we recognize these numbers, okay? Because they will come handy later on, okay? So where does this even play? Pythagorean theorem, irrational numbers. Well, the Pythagorean theorem is a theorem, and irrational numbers are a type of number, okay? So it's important that we understand the basics, like what are perfect squares, what are perfect cubes, and we don't even know what the root symbol does, okay? So let me ask you this question then. What is 3 squared? What does that equal? 9. Okay? Because 3 times 3 is 9. What is 4 squared? 16. Right? Because 4 times 4 is 16. What is 7 squared? 49. Then what's 10 squared? 100. So, if you know how to square numbers, that's a good start. Now, what is root 9? Technically, this would actually be the square root of 9. Square root of 9. For those of you who've already taken the 7th focus area, I think you might know what this is. The square root of 9. I'm not going to tell you what the answer is, but I'm going to ask it another way. What number times itself equals 9? What number, call it x, times itself equals 9? 3. The square root of 9 is 3, because 3 times 3 is equal to 9. Let me write that down. Because 3 times 3 is equal to 9. What about the square root of 16? What is the square root of 16? It's 4. Because 4 times 4 is equal to 16. Right? So you're just thinking of a number that times itself equals whatever's under the square root. Get it? Square roof, not root, roof. Sorry, bad joke. What's the square root of 49? 7, because 7 times 7 is equal to 49. Last one. What's the square root of 100? 10, because 10 times 10 is equal to 100. Now, let me push your thinking right now, okay? What do you think the square root of 19 is? What number, right? We're thinking of a number that number times itself equals 19. 19. You see how it's a little bit difficult now? I think some of you might be thinking, well, I think it's a decimal. And you're right. It is going to be a decimal. But between what numbers will that decimal be? Well, I'm going to give you some hints, okay? The number 19 is between which two perfect squares? Since we're taking the square root, we're talking about squares. 19 is between which two perfect squares? It's between 16. Let me use a different color, actually. It's between 16 and what other perfect square is it between? 25, yeah. Now, let's use purple, whatever. When you take the square root of these numbers, because we're trying to figure out the square root of 19. The square root of 16 is 4. We know that because 4 times 4 is 16. We know the square root of 25 is 5, because 5 times 5 is 25. And then here we have square root of 19. So, between what two numbers do you think the square root of 19 is? Between 4 and 5. And then you can make a guess. You can say, I think it's 4.5. And I really wish I had a calculator here, just like on the side. That would be really cool, like a widget. And I could show you that the square root of 19 is very close to 4. Actually, I don't even know if it's 4.5. It might be like 4.4 or something. But you get the idea. You now have a tool to approximate square roots. If you know what two perfect squares are close to it, you can estimate. Okay? So the square root symbol that we first saw is just a way to tell you what number times itself equals that number. Okay? Let's do another one. What do you think the square root of 144 is? 12. You got it. Because 12 times 12 is equal to 144. The homework for today, it's going to be a lot of practice with these square roots, okay? And I would first advise you to, do the ones that you can do without, do the ones you can do without a calculator first. And then once you can't do them with by yourself, then use a calculator, okay? You need to practice these skills. Now, I am going to, technically I should be waiting this to the very end. You know what, actually? Yes, I'm going to wait. I'm going to wait to the very end. So these perfect cubes, it's good that you can recognize perfect cubes, but we're not going to need them right now, okay? Just focus on remembering or recognizing perfect squares, okay? And I know I'm a math nerd because whenever I see a perfect square, I'm like, oh yeah, that's a perfect square. 36, 49, 64. So if you start recognizing perfect, like if you see the number 4 somewhere, I want you to think, oh, that's 2 times 2. Or if you see the number 196, oh, that's 14 times 14. I don't know. It'll just help you remember these numbers because square roots and the Pythagorean Theorem is going to be all about taking square roots, okay? So, I don't even know when I started recording and I don't know how long this video is going to be. So, I'm just going to, let's just do it. Let's just do it, okay? You're like, what are we going to do? I don't know. You're just saying we're just going to do it. So, one of the biggest things in geometry, and in algebra especially, is a Pythagorean theorem. I don't even know how to spell that. Pythagorean theorem. It's a theorem, meaning it's something that's always true. Now you're probably wondering, who's Pythagoras or Pythagorean? Pythagoras at first was believed to be a person, and this was way back in the day. I'm talking about like when people still you wore like what are those things called? Sheets as a dress. Pythagoras was this dude who loved mathematics so much that he legitimately formed, what's it called? Like a cult. He formed a cult of people that would get together and all they would do is drink and do mathematics together. Okay, you can look this up legitimately. Pythagoras, the Pythagorean cult. Now he didn't find this theorem, okay, the Pythagorean theorem. This theorem has actually been known to be true across thousands of years in in US history, in human history. Cultures across the world have discovered this theorem independently of each other. And I don't know why Pythagorean gets all the credit as being the one that discovered it. People in Mesoamerica, in China, in Japan, all across the world, India, there have been people in different times discovering this theorem. And it's so beautiful because even the Egyptians were using this theorem to create perfect triangles. It's amazing, okay? So this is what the theorem states. Oh my God, I can't even draw a triangle. If you have a right triangle, and a right triangle is just a triangle that has a 90-degree angle, okay? If you have a 90-degree triangle, if you have a 90-degree right triangle, and this side is called A, and this side is called B, and the long side is called C, and if you need to remember which one's the long side, it's always the one that's opposite to the 90-degree angle. If you have a right triangle with sides A, B, and C, where C is the longest side, if you have this, then the short side, or whatever, the side A, if you multiply it by itself, and you add it to the other side squared, right? If you multiply it by itself, it equals the longer side squared. This is always going to be true as long as it's a right triangle. Always. So you might be okay, you're probably not wondering, but I just want to say this because I'm a math nerd. You might be wondering, how did the Egyptians use this? Well, they knew that how do I explain this? You know what, let's just do an example with this so that you see that it works, okay? And maybe you can try this out at home if you have some yarn and a ruler. Like, you can cut out certain measurements and you'll see that you can create a perfect right triangle. So, suppose A is equal to 3 and B is equal to 4 and C is equal to 5. We're going to check if this right here is a perfect right triangle. Okay? So, we're going to plug it into the formula. 3 squared plus 4 squared is equal to 5 squared. We're just going to check if it is true. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. 9 plus 16 is 25. And, 25 is 25. 25 is equal to 25. Does that mean a triangle with side lengths 3, 4, and 5 is a right triangle? Yes. This is a right triangle. Let's do another one. And I'm just going to do random numbers, okay? A is equal to 3. B is equal to 12. and C is equal to 13. Okay? And it's important that you label which side is which side. C is always going to be the longest side, okay? So, using our formula, we can even draw the picture, okay? This is going to be 3, this is going to be 12, and this is going to be 13. Let's see if it works. 3, well, it's 3, so that's going to be 3 squared plus 12 squared is equal to 13 squared. 9 plus 144 is equal to 169. 9 plus 144 is 153. That's equal to 169. Is that a true statement? 153 is equal to 169? No. What does that tell you then? Is this a right triangle? You're absolutely right. This is not a right triangle. It has to be true for it to be a right triangle. Your homework will consist of you practicing all of the skills that you're saying on this particular assignment, okay? Now, I'm going to do one last type of example, and I'm going to call it a day because, trust me, this unit is supposed to be 2.5, 3 weeks long, but we're going to do it in a week. We're going to do it in 5 lessons, okay? Because a lot of you have already done the 7th focus area. And if you haven't, it's not that bad, actually. It's really straightforward. It's just knowing how to apply the formula, okay? This is not a right triangle. So, we're going to take a look at this example. Suppose you have a right triangle, okay? This side is 5, and this side is 12, but you don't know what x is. Actually, I'm not going to use x. I'm going to use c to make it more consistent. We want to know, find out what c equals, okay? So we know the formula, a squared plus b squared equals c squared. And we can use this formula here because it's a right triangle. It's a right triangle because it has this little square right here, okay? That tells you it's a right triangle. It doesn't really matter what a is or b, right? As long as you choose one of them. I'm going to say the side that's always on top, like this one over here, is always a. But that's just my thing. 5 squared plus 12 squared is equal to c squared. We're going to figure out what c equals. 5 times 5 is 25. 12 times 12 is 144. That's going to be equal to c squared. 25 plus 144 is 169. Now you might be wondering here, well, how do we solve this equation? Well, we're thinking of a number such that something times something, right? C times itself should equal 169. This is where you will start doing the inverse operation of squaring. Okay, just like the inverse operation of adding and subtracting or multiplying is dividing and blah, 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 the inverse of squaring is taking the square root, taking the second root, I should say, the second root. And it looks like this. Or if I want to be like a TikTok meme, and it went like, you're going to take the square root of both sides. Okay? I used red because I don't know why. Now, when you take the when you take the second root of a square, these cancel, right? I mean, that's the whole idea of doing the inverse. You cancel. So now you have c is equal to And what's the second root or the square root of 169? What times itself equals 169? I'm sorry, yeah. 13. So C is equal to 13. Your homework will consist of you just trying out these problems, taking second roots, square roots, maybe squaring some numbers, and then finding out if a triangle is a right triangle or not, and then, finding out what C is. And, actually, that was going to be my last problem, but I want to give you one more, okay? And it's going to be different. The only difference is, here's my right triangle. The only difference is you're going to be missing one of these right here. Let's say this is 10. Let's say this is 7. Okay? So we want to find, this is A, by the way. We want to find what A is here. So always, first things first, always write down the formula. A squared plus B squared equals C squared. Here we have A. Here we have B, and here we have C. So now we're going to replace the variables with what they actually equal. A is A, so it stays the same, A squared. B is 7, so that's 7 squared. And then C is 10, so 10 squared. So we're going to have A squared plus 49 is equal to 100. Uh-oh, how do we solve this problem? Yeah, it's not that bad, right? We got to get rid of the 49 first, and then we can undo the square. So the opposite of adding 49 is subtracting 49. So we have A squared equals 51. And then what's the opposite of squaring something or taking the square of something? Taking the second root. We're going to take the second root of both sides. This is going to cancel. So we have A is equal to the second root or the square root of 51. Now, 51 is not a perfect square, right? 51 is not a perfect square, so it's going to be a decimal. Now, if you have a calculator right now, please type in 51 into your calculator and write down the decimals. You're going to realize, wait, that's not cool, maestro. It's super long. And then I'm going to ask you, is there a pattern? Do you notice a pattern? And you're going to be like, no, there is no pattern. And I'm going to tell you, good. There should be no pattern because this number right here is what we call an irrational or irrational number. But we'll talk more about that next time, okay? Please be safe, wash your hands, practice